One of the things that we have learned is that all over the world are groups of individuals who have resided in those areas for long periods of time. And when we look at those groups, we can develop a unique signature for them, a unique DNA signature, so that when they travel all over the world and commingle with other groups of people, we can even pick them out there. So we can tell, in the case of a DNA sample, where an individual could have originated from. And that helps people, sort of, when you look at this, you ask yourself the question, what is a Hispanic? And because it's not a very good description. But yet, on our government forms, we all check off Hispanic, Caucasian, African American, Native American. These are all sort of misleading bits of information, because what we find out that within Hispanic populations, there is a tremendous variation from one individual to the next. Mm-hmm. And it's that variation that we're able to determine. And we use that in our medical products and diagnostics area as a means of determining diagnostics and also being able to predict whether individuals can respond to medicines or not.
Okay, I'm getting a question in from the chat room, and one of the individuals wants to know if you can identify body parts from war, such as GIs, who are for loved ones.
Yes, that's a very good question. Well, I can tell you that as long as the DNA has been somewhat preserved, and it usually is preserved in the what they call the deep bones, and as well as in the teeth. This is kind of a gruesome discussion, but as long as there is a bit of DNA that is preserved, we can determine. There's two kinds of matching tests, which is what the FBI uses. It's called the STR test. We do that as well. We use that as a quality control. Think of it as a barcode of your DNA. What it doesn't do is it doesn't tell you anything about the individual, in other words, description or any of that. So if we have, we can categorize human remain samples by regions of the world from which they come. So in the case of where you have a mass grave, we can categorize the individuals, and so that we could tell that some people are from Northeast Europe and some people are from Southwest Europe and other people are, Native American and African American and all that. And then what you do is you go in and do the matching, which is you run the STR, and then you run the STR of the family members, and then you can match them up that way. It's a much more efficient way of looking at human remains.
When it comes to, I want to say, standard error, so for instance, if you had my hair and you take it, you'd be able to tell certain things about me. What can you tell, and then from what kind of error do you have, or error percentage do you have on certain aspects?
Well, I guess we've run a couple of what I call remarkable test runs. Our most remarkable test run was we had an audience of around 650 detectives in Los Angeles, in which we did a live demonstration where we picked 20 individuals. The 20 individuals of the 600 some odd people that were going to attend sent in their DNA blind, and we ran their DNA, and then live on stage we matched the individual with their profile on stage. So I think that kind of speaks to, does it work? Yes, we matched all 20 of them. In the Louisiana serial killer case, there were 2 eyewitness reports that said that there was a Caucasian male in a white pickup truck. And so the task force was looking for that. When they sent us the DNA, we came back and said, no, you got some good news, got some bad news. Good news is we can help you identify this guy. Bad news is you're looking for the wrong guy. The man turned out to be 85% sub-Saharan and 15% Native American, so we gave him a description that we thought with, and that was the very first case that we ran. And within 6 weeks, they caught the guy.
All right, so let me ask you this, because that's amazing. What's the cost for a sheriff's department to run something like that past you?
Well, it varies because we've added on components now, and it starts off at about $1,000 a test. There's an eye color component. We actually can determine a person's eye color from the DNA. And there's also 2 further expansion tests on regions of the world that they come from. So, if we can answer the question right off the bat, then it's $1,000. If there's more information that's needed because that particular first answer to a question leads to another question, then we run the second test. So we run them. We don't run them all at once. We run them sequentially.
Oh gosh,
and,
there's just
so
so much.
It starts off at about $1,000 a test.
Oh, there's just so much I want to ask you. I tell you what, do you have the time to stay for an extra 5-10 minutes?
Oh, I will stay as long as you want, and I will come back anytime you want.
Oh, okay, great. Okay, so let me ask you one thing, and then we're going to move to a break, and we're going to keep you over and chat with you a little bit more. Richard, okay, so how the heck are you going to market this stuff? I imagine you're going to have to wait for some more funding, or because it sounds like you have a global product that everywhere in the United States and the world would want to be able to tell the eye color from a hair if there was a crime or something like that.
Well, we're working. We can't go into a lot of details, but we're working with some U.S. national agencies that are focused on. We're a sponsor of Amber Alert, for instance. And we're also working with, national agencies to help to try to identify missing person remains, and that's in progress. But, I can't go into a lot of detail about that right now.
All right. Richard, let me go ahead, and we got to take a hard break. When we come back,
Great.
We'll finish that, and then we have another about 5-10 minutes. We'll chat a little bit more.
Oh, that'd be great.
All right,
Thanks,
Richard Gabriel with us right now, DNAG, DNAprint Genomics. DNAprint Genomics. Stay with us. Market news first. News you can trust. Don't touch that mouse. We'll be right back.